Okay, so we're finally back. Today's video should be pretty quick. We're just gonna do tensor version of a dense layer. Alright, so we got tensor ops, which is right here. I moved the matrix ops file, so that's why that's different. Otherwise, hopefully I'm right on track with things. So I pre-made a bunch of stuff, but we'll walk through it. Alright. So first, this will be very much like the matrix version of the layer dense. So you could do this on your own if you feel like it. A few different inputs to put in. Weird. Okay. But yeah. So we'll just have the constructor as usual. A few extra parameters here though. Maybe just one. But we'll be renaming some of them. So we'll have batch size, sequence length, which will be obviously batch size will be how many different samples we have, independent samples. Sequence length will be assuming that this is for a decoder transformer for a language model. Sequence length would be the max length. Well, during training, it'll be the length of how many words in the sentence to, well, not words, how many tokens in the sentence to make the next prediction. And input dimension, you could also call it the embedding dimension, the out dimension. Out dimension, and then bool for bias. And so yeah, it's should be almost the exact same, except one extra piece, and I forgot a colon there, and just renaming things to be more like a large language model or a language model. And we'll have the forward function is a tensor. The backward function and then I'm going to just start copying some of this stuff. I'll do it in chunks though, so we don't miss anything. I think that needs that. Alright, so a tensor for the output, for the derivative of the inputs, for the biases, derivative of biases. And then the next section all the usual fun stuff, weights, derivative of the weights, layer bias to say we are using bias or not, number of samples, the input dimension, the output dimension, and a copy of the inputs for going on the backward pass. It has been a while. I don't remember why I don't have all of these inputs being copied into this. 2, 3, 4. I don't have batch size in there. I must not need batch size anywhere. Alright, and then we'll just do the constructor definition. Events. Excuse me. Alright, this dot input dimension equals input dimension. This dot in out equals the output dimension. One second. Okay, then we'll have this dot n samples equals, should equal sequence length. Is that right? Okay, for some reason we have batch size times sequence length. Let me take a look here real quick. I guess that is the total number of samples. Independent samples would be the batch size, and your training on each member of the sequence length, and that would be a total of number of samples. Let me see what I used that for, though. I don't remember. I built this out a while ago to make the video and then got busy. Do I even use this? I don't even use this anywhere. So I could ignore that. That gets used. That gets used. That does not. Sorry, you couldn't even see. This doesn't even get used. So for now, we're just gonna comment that out. As of yet, we do not need it. Alright, so we have this dot layer bias equals bias. Yeah, just so you know, I can do that, hit dot, and hit layer bias, and once I hit tab, it'll convert to that. I don't know if you also have that. Alright, this dot weights equals tensor put dimension out dimension tensor tensor ops tensor I could definitely make this more clean, but this is how it is for now. I probably should have, like, here in making this, should have returned. Where am I at? Walkthrough. This equals tensor should have make it a return so that I can set that equal to that. That's probably a safer and better practice, I'm guessing. We'll have weights dot random fill negative 0.1 f to 0.1 f. If layer bias biases equals tensor. I guess you probably know sometimes I do this dot weights and other times I do like weights. I guess they both work just fine. I don't know which is like better practice. Maybe you should always do this. And really for the transformer, you do not need, I believe, you end up not even needing biases for your, I guess that's just for the self-attention. Maybe you probably do need it for the feed-forward networks, so never mind to that. Let's see, random fill, set it for deep biases, make room for them, which is 1, 1, ouch dimension, just like biases. D weights, tensor 1, input dimension, output dimension. Yeah. D inputs equals tensor of batch size, sequence length, input dimension, layer inputs, and finally okay, allocated all the memory. We are good on the constructor. Next we have the forward function. Copy over the inputs to the layer inputs. Trying to remember, does this copy by value? Because really you could make layer inputs just a pointer to a tensor and have it point to the inputs tensor itself. That way you're not creating a whole new tensor. Yeah, that would be the better way to go. Just an FYI, you can choose to do that. Where am I at? It'd be way faster in training. So yeah. Alright, size T. Oh, okay. Size. So this is what I ended up doing rather than doing the number of samples. I do inputs dot shape dot dims 0, and then we do the same thing for sequence length. Do BMM output inputs weights. So that's the batch matrix multiplication. Different way you can do this is like, okay, so what I'm going to do here is do the multiplication and then add on the biases. Would have been better to do a batch multiplication and another version that's a batch matrix multiplication with adding biases in here in this function. So two different versions of this function, one with biases and one without. But being lazy. And it's faster because you're going through all these for loops in here. Now we're just going to re-go through those in here, which really could have just packed this into these for loops. Would have been better. Make it B, batch size. S for sequence length. And one more. And J for nothing. We're going to find the index of our output, and it'll be the same index. Or no. Okay. Yeah, we'll find the index for our output, which will be B times sequence length times in out plus S times in out plus J. Okay. What this is, J is what we're going to loop over. Let's see. Okay, so we have batch size, sequence length. I'm trying to imagine it here. Batch size, sequence length. We're going to have outputs. Batch size, sequence length. And within each, so this is like number of samples. And with that, for each sample, let's see, the output will be, here, let's go back to output real quick. batch size, sequence length, out dimension. Yeah, because you're gonna do the inputs, which is gonna be batch size, sequence length, and input dimension, which is the same as this. Multiply with the weights, you'll get a batch size, sequence length, and out dimension. Okay, yeah. Batch size, sequence length, out dimension. Yeah. So, and then biases, right here are a 1, 1 out dimension. They're going to be, they would match the dimensions of the weights, except not the first dimension, just the second dimension, because the weights are input dimension by output dimension, but everything in the input dimension gets summed down to one spot on each dimension of the output dimension. So biases are just a vector. And so we have an index for the output, the batch for every member of the batch, which, to skip ahead, for each batch is, this would be 0 times whatever this is, and then 1 times skipping all of the sequence length times the output dimension gets you to the next sample, the next independent sample, which is from the batch, plus S times N out for each sequence. Each token is what this one is. Each token is out dimension long. So you want to go to each new one, 0, and then the next token starts at 1 times out dimension. Yeah. And then go through these out dimension with J. And with that, output dot data IDX. So every place of the output, every output will be added with biases dot data J. Let's see here. I forget what I was going to look for right there. Oh yeah, output.data. Going back to the tensor, I'm just reminding myself of stuff. Tensor. Vector. Okay, data is the vector. Yeah, that's what I thought. Okay. Got the forward pass. In the next video, I'll just go to the next video to do the backward pass. And then, possibly in the same one, move on to ReLU. So, that's all for now.